Hello, welcome back once again. In this video, we're going to discuss this given limit. Limit as x is approaching 7 of 2x divided by x minus 7. Now, when you make your direct substitution here, you're going to get 2 multiplied by 7 divided by 7 minus 7, which is equal to 14 divided by 0. And we know division by 0 is undefined, but in calculus, it is equal to positive infinity. Now, you see, when you plug in x equals 7 directly into this function, that gives either undefined or positive infinity. Okay, but if you try using the L'Hopitus rule here, if you use the L'Hopitus rule, remember, according to the L'Hopitus rule, the limit of a function, let's say x is approaching a. Let's say we have f of x divided by the h of x. So this is same as the limit as x is approaching a. Up there we find the derivative with respect to x of f of x, right? And the same thing happens at the denominator, right? This is h of x. Okay, so this is the L'Hopitus rule, okay? Now, let us apply the L'Hopitus rule and see what happens. Remember, with direct substitution, we get undefined or positive infinity. Now we have the limit as x is approaching 7. We have 2x divided by x minus 7. Now with the L'Hopitus rule, we have limit as x is approaching 7. Here we have d dx of 2x divided by, here we have d dx of x minus 7. So this is equal to limit as x is approaching 7. Up there we're going to have 2. Then divided by, down there we're going to have 1. And you can see that the limit of 2 as x is approaching 7 is just 2. Now you have this option here, and we have this second option, which is 2. You can see what is going on. We keep getting different values. Okay, now let's do the following. What if we decide to divide the numerator and the denominator by 7? Well, if you do, by x. So if you do that, you're going to have 2x over x divided by x over x minus 7 over x. So I think that is going to still give us division by 0, right? Okay, no need for that. But we need to think properly. We know that a limit of a function is defined when the both sides of the limit is defined. You see? Okay. Let's say we have the limit as x is approaching a of f of x. Let's say that this is equal to L. Then this will be true, or this limit will exist if the both sides of the limit is approaching the same value. This is what I mean. The limit as x is approaching a from the left of that same function of x must be equal to the limit as x is approaching a from the right of that same function of x, and this must be equal to L. So when this condition holds, then the limit exists. But if the limit of a function from the left is not equal to the limit of that same function from the right, then the limit is said to be DNE, which means does not exist. This is nice, okay? So we're going to check the sides or the two-sided limits of the given limit of the function. That is the limit as x is approaching 7 of 2x divided by x minus 7. So we're going to check the two sides of the limit and see what happens. Okay, now let's start with the left side. Limit as x is approaching 7 from the left of 2x divided by x minus 7. So let's start with this one. Okay. Now let's do the following. Say we have, so how do we make this table? So we have the following. So let's see what keeps happening. Now we know if x is approaching 7 from the left, it can be 6, right? It can be 6.1, it can be 6.2, it can be 6.3, all the way it can be 6.9, it can be 6.9999, but not exactly equals 7. You get the idea? So let's start with 6.8. So 6.8, okay, this is what we're going to do. Oh, sorry for that. So say we have the function here. Oh my God, so sorry for that. Okay, so we say we have 2x all over x minus 7, and say here we have what the limit is approaching. Okay, so when x is approaching 6, or when x is equal to, so let me make it clearer. Okay, so when x is equal to 6.8 here, so we're going to have 2 times 6.8, 2 times 6.8, right, divided by 6.8 minus 7. So that's gonna give us negative 68. So this is giving us negative 68. So when x is equal to, let's say we have to use 6.89. Let's see what keeps happening. So when x is approaching 6.89, so that is giving us negative 125.27 approximately. Now you can see what is going on. As x is approaching 7 from the left, this limit keeps decreasing, right? You can see what is going on. So it is going all the way to negative infinity, simply like that, okay? Now let's check the right-hand side of this limit. So let's say we have limit as x is approaching 7 from the left of 2x divided by x minus 7. So here we have 2x divided by x minus 7, and here we have what the limit is approaching. So let's see what happens this time around. So let's pick the point. Remember, if x is approaching 7 from the right, it can be 7.1, right? It can be 7.01, it can be 7.001, it can be 7.0006. So I think the 7.1 doesn't make sense, right? That is not necessary. So it must be 7 point, let's say 0.001, okay, and so on. So let's pick 7. X is equal to 7.01. Okay, so now if x is approaching, or if x is equal to 7.01, so let's see what is going to happen. It will be 2 times 7.01 divided by 7.01 minus 7. So that is giving us a huge number, which is 1402. Okay, let's check for 7.001. So that is 2 times 7.001 divided by 7.001 minus 7. Oh my God, this keeps increasing. So you can see as x is approaching infinity, right, the limit of the function is approaching positive infinity. Oh, sorry. Oh my God, what am I writing? As x is approaching 7 from the right, I mean, by the way. So sorry for this mistake. That's a silly mistake. So, and here we remember that as x is approaching 7 from the left. So now we can see clearly that the limit of this function from the left is not equal to the limit of this function from the right. So what do we say? So we say that the solution to this limit is D and E. So the given limit does not exist, and this is the solution. Thank you for watching. Please, if you really enjoys this video, kindly subscribe to this channel. Also like, comment, and share.